Hello, I'm Brian Kern, and along with my partners, Anna Velasquez and Daniel Hum, we've chosen the topic of hands on learning in computer science curriculum. Why? Because engagement has been an issue for educators throughout the history of education in computer science. Okay? It has grown since coming back from our distance learning break. Helping students engage and interact with computer science is critical for them to understand concepts, okay, not just in computer science, but in any content area. The more active the learner is, the more they comprehend and engage within that material. Bringing kinesthetic learning into computer science classroom helps students engage and understand the material in a conceptual manner. So, we chose this as our topic to help focus on the kinesthetic learning aspect of computer science and what it promotes. Um, what does it promote? One, a much more active learning environment for participation. Two, a deeper understanding of the chosen computer science curriculum and concepts, which in our case study, we chose algorithms as our focus area point. And three, a hands-on learning of computer science concepts and curriculum, improve problem solving and critical thinking skills. So what we have put together in this presentation is 3 example lessons, okay, from the classroom for the K through 12 curriculum, one from each level. You'll see an example lesson from the elementary level, an example lesson from the middle school level, for 6th through 8th grade, and then an example from the high school level. In each of these lessons, you'll see various examples of hands-on programming activities that will allow students to engage in the CS curriculum in different and unique ways in order to strengthen their knowledge of the focus area of algorithms.
So I'm Daniel Holm, and before we get into the lesson, we're going to talk about how kinesthetic learning, by using hands-on, promotes 21st century learning. 21st century learning is collaboration, communication, critical thinking, and creativity. And the focus on problem solving through kinesthetic learning has a significant impact on student performance in programming and critical thinking and logical reasoning, which are essential skills in the field of computer science. And by fostering a collaborative learning environment through kinesthetic learning, we are preparing our students for the real world demands of working in teams and delivering impactful projects. And so, this is why Anna, Brian, and myself chose kinesthetic learning for computer science because of uh, the engagement and the impact kinesthetic learning has had on computer science. So, working with Brian and Anna, Brian works in middle school and Anna works in high school. And since I'm a professional development specialist, meaning I don't technically teach students or have a class, um, I volunteered to take elementary. And so, what I did is I connected with a feeder school and I had my connections with another professional development specialist meet up with a fifth grade teacher, and I asked if I could teach a computer science lesson in their class using hands-on learning, and they agreed to it. And I suggested the flowchart relay, and they thought that was a great idea. So my lesson for the kids is only 1 hour because that's the time I could get on the campus. The students I worked with are dual immersion, so they both have classes in English and they have classes in Spanish. They have had some computer science background. They got to work with some of the Lego robots, but not an extensive amount of computer science, not a lot of coding background. And so going in, I wanted to do a somewhat introductory lesson with teaching them about flowcharts and conditionals and bringing in kind of like that pseudo code so that they see what programmers are doing. So, uh, the first thing I did is I wanted to make sure that they were aware of the objectives. So the things that we wanted to cover in the lesson was making sure that they understood the basics of a flow chart, um, how to use a flow chart, know what the if else statements are, that they could create their own flow chart, and that they could execute a flow chart in the relay race. The materials I needed for this, because this is kind of like an unplugged activity, um, I use blank paper so that they can create their own flow chart, and I also use Dollar Tree items, which we'll get to later, for their flowchart relay. So in the lesson, one of the main things I did want to talk about is conditionals. That hey, it's like if they're going to do this, else they're going to do this. This yes no statement. I gave them some examples about Sparky barking. We did a couple other examples, and then I also showed them a video from Vocabulary. It's called coding conditionals, and with that, I wanted to the music. It's in the form of a song. It sings to them about conditionals. It shows them if, else, and also nesting. And so that whole purpose of that was to make, uh, hopefully, make it interesting for the students, but also to use it as a mnemonic device to help them remember how conditionals and how flowchart works. So with that, I went through our agenda was to go through what a flowchart is, what a conditional is. They make their own flowchart, build a flowchart for the relay, and execute flowchart relay in teams, and then finally a reflection. So the first thing I after I introduced what a flowchart was, gave them some examples, I had them use from the 21st century learning some critical thinking and creativity. I had them be required to use two images or concepts of conditioner and a squirrel, and they had to build a conditional uh, with a flow chart using that. And I asked them to be as crazy as they could. The students built conditionals, and then they shared them out. This way, I could see their flowcharts and also hear it amongst the class. And that was kind of like a informal assessment for me. They were sharing with each other. They were communicating their flowchart, and they were also their answers were super creative. Um, After we did this, uh, we got into the flowchart relay. And so what I did was I had like a plastic bat and ball, jump ropes. I had a deck of cards, some foam dice, mirrors, ornaments, these little kind of like badminton rackets with some cat toys there. They had to hit it, and I talked to them a little bit about how each of the games would work. And I but the students as a class, they came up with they collaborated on like what number would have to be rolled on the dice, how many times they would have to hit the cat toy with the badminton racket, um what would lead to what situation, if this happened, what would happen next. And so the kids use their creativity, their critical thinking skills of what would be beneficial or what would be kind of fair in the relay race to do this. They built a flow chart in which they knew they were going to have to race. So it was really fun and interactive activity where the kids got to participate. They had a hand in choosing what went into the flow chart, and so it was great. And then after that, they actually got to physically do the flow chart. And so each person was in charge of what would happen if the conditional. So if the person in the relay was able to hit the cat toy on the racket 10 times, then they would have to do one activity. But if they dropped it or couldn't do it 10 times, then they had to do another activity. And the person in that next line was the next person in the relay. And sometimes kids repeated, but they would switch turns and they would carry out the relay until the whole flowchart was finished. And we had a great time. After that,
Go.
I had the kids actually write down where they saw flowcharts in their life. Maybe it's with parents telling them to do the chores or they're going to get in trouble, um, or where they could see that in like their subjects, like, hey, if I divide by this number, then this will happen. But if I divide by this number, then this will happen. So I wanted to have them make those connections in their reflections. So what they did is and this was an individual activity, but they wrote down and then shared out their reflection of what happened, or where they saw uh, flowcharts in their lives. And through this whole lesson, using this kinesthetic learning, I could see the kids interacting with each other. They showed conceptual understanding and mastery of this. So it was a great lesson, and they asked me to actually do this with another fifth grade class. So I'm really excited about it. Some other ideas for kinesthetic learning activities for computer science in the elementary school is doing an algorithm dance, or some other unplugged activities like the flowchart relay. There's other unplugged activities that we can help you find out. There's another, not a flowchart relay, but human flowcharts, physical sorting, actually having kids move stuff, algorithm relay races. That's always good. Debugging, scavenger hunt, robot programming, and just regular puzzles and games, and just having the students make those connections to computer science and seeing how that there is that relationship. And all of this is to show that computer science is um, just more than just pressing buttons on a keyboard and seeing symbols on your screen, but it's understanding the concepts behind all of those symbols and characters that you're putting in, and what that actually means, and working together in using those skills. So it was a fantastic lesson, and I look forward to doing it some more.
So today we are going to kick off a short unit about how computer scientists think about problem solving. Okay? A really important skill, okay, will be recognizing patterns and similarities. So I'm going to ask that you take out your interactive journals and you reflect upon these two prompt questions regarding what makes two pieces of code the same, and could there ever be two pieces of code that you consider to be the same, even if they are not identical? Okay, so now that you've had a chance to answer those two warm-up questions, what we're going to do now is, in a warm-up activity, okay, I want you to look at these 10 problem questions. And on a separate sheet of paper, what you're going to do is you're going to go around the room, interact with other students in this classroom, and you're going to find the answers to these problem questions. Okay? So I'll give you a short time to do that. Look at the problems first. Okay? If there are any questions, you can clarify them before we begin this activity very shortly. All right? Okay, now that you've had a chance to go through this activity and complete it, with your other classmates, let's look at and discuss some of these problems here. As we can see in problem number 1, where we find a person whose birthday is before yours, problem 1 is similar to problem 2, where we find a person whose birthday is after yours. So problem 1 and problem 2 are very similar problems. Problem 3 and 4 are similar, but you need to talk to every other student to answer it. Okay? You only need to keep track of the closest birthday, okay, that you've heard so far. However, if we look at problem 5, this is easy to solve as soon as you solve problems 3 and 4. Okay? Problems 6 through 10. Problems 6 through 10 require you to have written down everyone's birthday, likely in order. Okay? And problems 7 through 9 are the same problem, but for different numbers of people. Okay? So whatever strategy you use for one of those, 7 through 9, okay, one of those would be helpful to solve the other one. So if you chose to use one way to solve problem 7, then you could also use that for 8 and 9 as well. Okay? And problem 10. Problem 10 is just a different version of problem 7. Okay? But instead of finding the smallest gap, you are finding the largest gap. So I am going to put a couple reflection questions now that we've had a chance to do this, a reflection on this activity. So real quickly in your journals, can you please write down a couple of responses to these problems? Okay. 1, I want you to share with someone how you went about solving each of these problems. Write it down in your journal. Okay. And then the second one, which problems did you need to do something similar in order to solve them? Okay, and we've just briefly discussed that. So please take some time now to answer and to carry out the first prompt and answer the second one. Thank you. Okay, now that we have had time to discuss that with our neighbor and to reflect on that question, the first thing that we need to think about as computer scientists is, what is a problem? Okay, we just looked at those 10 problems, okay? And as we discussed the similarities and differences between those problems, right? If we solve one problem, we may actually solve another, or at least have a good idea, okay, for how to start solving another problem that we're faced with. So as computer scientists, it is important to ask, have I seen this problem before? Or how is this problem similar to others that I've solved? So what we're going to do today in our activity, okay, with these real life algorithms, we're going to put this to the test. So I'm going to be handing you out a worksheet, and you're going to be working at your tables in small groups. Okay? And what this activity is real life algorithm of paper airplanes. So we can use algorithms to describe things that people do every day. So in this activity, we are going to create an algorithm to help each other make paper airplanes. All right? So you're going to follow the instructions on here by cutting out the pieces of the steps that you think is the proper set of instructions to make a paper airplane. And then we are finished, and you're going to glue those steps in order on a separate sheet of paper. And the end result of this is you're going to hand this to a neighbor, and then they are going to follow your steps to make a paper airplane. So I'll give you some time to do that now, and then we'll come back and discuss and reflect upon this activity. Okay, so now that we're done with that, let's wrap this up and kind of review that activity. So how many of you were able to follow your classmates' algorithms to make your airplanes? Did the same exercise leave anything out? Did the instructions that you got, this activity that you got from somebody else, did it leave anything out? What would you have added to make the algorithm that you were given even better? what if that algorithm had only one step? Like, fold a paper airplane. What kind of result do you think you would get from that? Right? Would it have been easier to make an airplane if there was only one step, or much more difficult? And what if there was 40 steps to make a paper airplane in their algorithm? And then lastly, when you reflect on these questions in your journal, is what was your favorite part about this activity of making paper airplanes, and then following a set of instructions that someone else made for you? Please answer those in your journal right now. Okay, now that you've had a time to reflect on those wrap-up questions regarding the activity, we have one more assessment piece to do here. Okay, so with this worksheet that you're going to get now, you will be assessed on your ability to recognize and explain algorithms. So on this worksheet, okay, it's going to help you be able to explain in a couple different ways about what we learned about algorithms today. And that is a list of instructions for accomplishing a task. That's all an algorithm is, right? We follow algorithms every day when it comes to activities like making your bed, brushing your teeth, making breakfast. Those are all algorithms if you think about it, okay? So these images are not in order. You're going to put them in order. You're going to explain what is going on in the top portion, and then in the bottom portion, you'll have time to reflect on the algorithm that you came up with for making paper airplanes, okay? Using the steps, maybe not using all of them, maybe choosing only to use 6 of these steps here, okay, to accomplish the goal of setting out a plan to make a paper airplane. And you can have 2 different versions at the end. Okay? So you will have time to do this and wrap this lesson up in learning about problem solving, sequencing, steps, and algorithms. So at the end of this middle school lesson, this is where we could wrap it up in the vocabulary that they would get out of these 2 activities, one being more hands-on, the other one at the beginning where they got to go around and find information out from other students. They would be learning this sequencing of problem solving, and in essence our goal is to teach them how in middle school what an algorithm looks like, to identify that, to identify a problem, and then come up with a list of steps to solve that problem. Okay. So this was generated as a middle school lesson. I know there was a lot of moving parts in this. This could be carried over from one day to a 2-day lesson, not necessarily in a 50-minute lesson plan. So sometimes when I have students carrying out lessons like this, where they're moving throughout the classroom, I do split it up into 2. Or you can choose to do one or not the other. So that was my presentation to the students as far as hands-on learning of an algorithm.
Bye, Maya. Have a nice break.
Grayson, I'm gonna give you my hot Cheeto. And I'm gonna take your stuff on.
That's for my helpers when they're done.
Yo, put it back down. I don't want Sour Patch.
You guys, will we come back the week we come to school? Are you gonna see her again? And then just put the Sharpie in that, see that Tupperware right there? That plastic container. Yeah. No, in the one with the pastels. Oh. Just throw it in there. send this here for you, and then everybody's work.
I can imagine you skating. Ooh, I know how to skate. I think my mom has skated, like those like ice skating ones. And she doesn't use them. So I use one, and my sister learned before me. Okay, I'm gonna do it like this. No, it's not like this. Look, it's gonna look like this. Exactly. Okay, I'm
Fold corners sides to center.
side.
This is what it looks like. It has this. Oh my. Oh my.
Wow, that's my first. I'm gonna pull this out, the sides down. Huh?
You're so preppy.
Oh.
I'm crying. You wish.
Three, two, one.
Why was the farthest?
In this portion of the presentation, the hands-on learning activity chosen for students was to build a cyberbot. This is for the high school activity grades 9 through 12. This activity is for students in my Advanced Placement Computer Science Principles class. The cyberbot activity involves a combination of elements in cybersecurity, programming, and robotics. The cyberbot is used with the microbit microcontroller and is designed to teach students about their cybersecurity concepts in a hands-on, interactive way. Some of the objectives that students need to make sure they understand are the basics components of Cyberbot and how to program it using Python. The students need to be able to write and execute simple programs to control the Cyberbot's movement and sensors. The prior knowledge that they need is they need to know how to program a microbit. The materials, Cyberbot kits for each student or group. In my class, students were paired with a partner, so groups of two. Computers with Python programming environment available, USB cables to connect the Cyberbot to the computers, a printed reference materials or links with Python programming and Cyberbot components. The first part was to go over all of the pieces and make sure that students understand how they're going to connect things in order for them to complete their Cyberbot robot. I needed to make sure I explain the connection between the microbit and the cyberbot. They need to understand that students are going to program their microbit to run the cyberbot. Students were also given the kit and the link to the instructions on how to assemble the cyberbot in this part of the presentation. Students were given 2 days, 2 class periods.
Oh, you
to use their cyberbot.
No, wait, just in case. Okay, I don't want to mess this up.
And then you just need to put that.
Crazy, I know. I think it goes like this, right?
Oh my god.
Yeah, surely it'll go like this. Because
Which is it?
surely, okay, what's the first step?
In this first video, students were given the parts of their cyberbot and they were asked to use the instructions using learn.parallax.com to begin to build their cyberbot. So they have all of their pieces and materials that they need out, including the instructions from parallax.com.
And everything.
So you're attaching your servos to your cyberbot? Yes.
In the second video, students are learning what the servos are going to do and how they're going to need to use those to run their wheels on their cyberbot. The next piece, students were asked to open their Chrome browser and open python.microbit.org. They were going to connect their microbit to the computer. In this piece, they're going to also test their servos to make sure that if they say they want the cyberbot to move forward, it moves forward, and if they want it to move backwards, it moves in the appropriate direction. They're also going to code their program based on which program they chose and what cyberbot they have. In this piece, I observed students' engagement and understanding during the activities, and I got to review the students' written programs and their ability to control the cyberbot's movements. So, based on which program they chose and which cyberbot they built, this is where I'm testing to make sure that their code matches their project.
All right, so on the Cyberbot with Arduino, we have the infrared sensors so that it doesn't crash against the wall. And on this Cyberbot, we have the whiskers that are gonna make it so that it doesn't bang into the wall. So let's go ahead and test it.
Once students learned about the components of the parts of this is a robotic part where they had to build the robot. They also learned how to build it, they had to learn how to code it. And the last piece that my students did was complete a written response portion where they were given a series of questions that they had to respond to. One of them being, when creating your project, what worked and what didn't, and explain. What was the hardest part of the project? And again, making sure that they're having fun with their hands on activity to make sure that all students are learning.
So, in conclusion, kinesthetic learning and computer science work really well hand in hand, because what happens is the students really are participating and getting involved with the concepts and the topics. They're using interactive simulations. They're doing activities where they're um, learning exactly what computer science is truly teaching, and they're understanding on such a deep level. And so, as teachers, we need to make sure that we're bringing that approach that brings these 21st century skills like collaboration, having them work together, communicating their ideas and sharing with each other, critical thinking where they're using the idea and applying concepts not just to computer science but to what the way the world works, and they're using their creativity to come up with new ideas and making those connections between concepts so that they see it's not just um, pigeonholed ideas, but they're all interwoven. So as we go forward with computer science and teaching this to our students in our education system, we want our kids to be actively participating. We don't want them to just be passive learners. We want them manipulating objects. We want them to really dive deep, working together to help them really master the computer science concepts, especially because right now with artificial intelligence being able to spit out code like this, but students really have to be able to decipher what code matters and what does it really mean, and what should go where to make a program work correctly. And so again, so what do teachers need to do? They need to plan strategically. They need to make sure that the schools or our systems are providing the resources so that our kids have these opportunities, and the teachers have the resources to bring these activities to the students, so that that computer science, it doesn't seem like something that's just old and dusty, but it's so engaging and lively, and is full of like puzzles and games that teach these strategies. Is This is why kinesthetic learning and having our kids working hands-on in computer science will hopefully encourage more students to pursue computer science and see the relevancy of why it's so important that this is something all students need to know, especially going into the world that we live in today. Thank you so much.